Hey everyone, in this video I want to talk you through your shutter sync speed. Why is it that your camera is limited in the speed that it can sync at? What is mechanically happening inside your camera to cause that? And what does it mean for your photography?
Hey everyone, jump over to mattgranger.com, and if you haven't already, sign up for the mailing list and you'll get a free instant download of my new guide to improving your portraiture. This goes through everything you need to know, from finding models, coming up with concepts, working out lighting and posing and angles, and how to find great locations to create really unique portraits.
So no doubt you've probably heard of your sync speed of your camera. You know, the Nikons generally in DSLRs are 1/200th of a second or 1/250th for high end. Canon, the high end, also go up to 2/50th, but a lot of their mid-range and some of the high end only go to 1/180th or 1/200th. So a little bit slower there. Now, what it actually means, a lot of people have written to me wondering if it's something that could be fixed up with firmware. It actually can't, unfortunately. It's a mechanical aspect of your camera, and it's to do with how it's been engineered. It's a physical limit. So when we take a shot here using my old Olympus OM1, here at 1/1000th of a second, you hear the noise, and it sounds like one, maybe two movements. You just hear it opening and closing. When you slow it down to, let's say, half a second, you'll definitely hear the two movements here. Yeah. Okay, but what's actually going on there? There's about 4 movements, not just 2. So the first thing that happens, your camera, if you're using an autofocus camera, maybe a modern DSLR, it uses the mirror actually, bouncing the light up through the pentaprism to do the focusing, to do the metering, to do all of that tricky stuff. Then, once it's all locked down, you hit the button, and the first thing that happens, that mirror flips up out of the way. But that's not exposing your sensor just yet, or your film if you're using a film camera. Your camera then has 2 curtains inside of it, and they either move up and down or down and up. Some of the old ones I think even went left to right. But essentially, your first curtain opens, which then exposes the sensor or film plane to light. Then, after your exposure, let's say 30th of a second, after the 30th of a second has passed, the second curtain moves in the same direction as the first, closing the exposure. Then both of them reset to where they were at the beginning, and the mirror drops down. So all of that happens in that one noise that you're hearing. Mirror opens, curtain, curtain, mirror closes, and both curtains reset. Your maximum sync speed then is the longest time that your camera has been engineered that it can have the 2 shutters open before the second shutter needs to start closing. So let's say my D810 that I'm filming on here is 1/250th of a second. So it can get the mirror out of the way, open the first curtain, and stay open for as fast as a 2/50th of a second, both curtains, before the second one needs to start closing. If I get to 1/320th of a second, for example, the first curtain hasn't quite fully opened before the second one starts to close. So then they're moving together. Now, as you go faster and faster, 500th, 1000th, 4000th, 8000th, you'll find that say at 500th, it may only be open 2/3 of the way before the second one starts closing. Through to 1000th, and then 2000th, and by an 8000th, essentially, as soon as the first curtain opens, the second one is instantly moving after it, just painting this little strip of light across your sensor in much the same way that a photocopier does, just moving that little beam of light across. Check out this clip filmed by the slow-mo guys. They're showing in up to 1000 frames per second how it looks when your DSLR is doing this. They're shooting a Canon 7D. It's a really informative video. I'll link to it in the caption below. I really love watching this slow-mo stuff. But you really want to think about that moving line as being, it's a fixed engineered thing. That's not something that can be fixed with firmware when we're talking about a real shutter speed. So if we fired our flash faster than 1/250th of a second, that second curtain is going to be in the way, which means you'll get a black bar coming across where the flash didn't hit your sensor, it didn't hit the scene in that area. So that black bar is essentially what your ambient light was. Now, if you get a flash that will do high-speed sync, it may let you go all the way through to the fastest shutter speed your camera allows, which is like 1/8000th of a second. But note, that's why those flashes cost so much. Instead of a normal flash that just bursts off, those ones will actually be firing lots of bursts of light, little pops of light, to match that moving little slice of open exposed sensor to paint the light all the way across the sensor. Pretty amazing that they're able to time it right and you don't end up with little bands that are slightly brighter or darker than others. So really intricate and technical stuff. Now, of course, there's other things on the market now like mirrorless that give you a silent shutter option that use an electronic shutter, and that essentially isn't using the shutters to the curtains to restrict the light. It just turns the sensor on and off, but it still does it in a top-down way, in the same way an iPhone does, which is why you can sometimes get banding, like in this test shot that I got when I was testing the A7R2's silent shutter. You can also get cameras like old medium formats like my Hasselblad, where the shutter is actually built into the lens and it's a leaf style shutter, and that will let you sync your flash up to any shutter speed that the camera can do, which is great, but they tend to only go up to about an 800th anyway. Why would you want to go faster? Well, essentially it allows you more flexibility in terms of being able to control the light in your scene. If you could go to 1/8000th of a second at f1.4, you'd be able to shoot outdoors and get a really shallow depth of field but still control your ambient light with the fast shutter speed. If you're limited to 1/250th on a bright sunny day at your base ISO, at 1/250th at f1.4, you're likely to overexpose, so being able to add flash to the scene is really difficult. Get a fast shutter speed, you can cut that ambient down and then use flash to fill in the areas that need it. So I hope that makes sense. Leave me any questions or comments that you have, and if you want to learn more about what's happening inside your camera and how you can make use of all of its features and start to use, understand, and work with light to create really interesting and dynamic shots, check out my Take Control of the Light video series that I filmed with Tina. It's filled with lots of interactive exercises that you do and videos showing Tina going through the exercises as well to help you learn. Thanks, and I'll see you soon.